Thank you, Tariq. I appreciate the introduction. While I do some window management here, while I try to share my screen, I will say that Eric's talk was just, man, ideas coming out his ears. That was amazing. How much he had to say. It would take me days to unpack everything. This one is way more focused. So for better or worse, we're going to talk about a much narrower topic. So unless someone tells me otherwise, I'm going to assume that you can see my slides. And let's just go ahead and jump in. We've got a lot to talk about in only half an hour, so I'm going to not waste any more time. I'm Chris Cowell. Currently, I'm a senior instructor for GitLab, so I teach our customers how to use our software. And I got interested in static testing about 6 months ago when I started working for GitLab. Static testing is one of the features that GitLab offers. If you store your code in GitLab, then you can do static testing for free on it. And I thought that was pretty cool, but I didn't really know anything about static testing. I had the vague sense that it was this kind of magical thing that probably didn't work as well as it was advertised, because it's kind of like you're getting testing for free without having to really do anything. And I was skeptical, so I never really paid much attention to static testing until I started working for GitLab, and I was forced to pay attention to it because I had to teach our students about it. And as I learned more about it, the more impressed I got with it. So I think it's a really neat technology, and I want to share some of what I've learned about it with you today. I do want to clarify, this is absolutely not an ad for GitLab. Static testing is available in lots of different places. So this is about static testing, not about GitLab. Okay, I'm going to be talking at you for 30 minutes, so sometimes it's nice to know a little something about the person who you've entrusted your time to. As Tariq said, I was a developer for a long time and test automator for a bunch of companies, big and small. And as Tariq mentioned, I kind of realized I like people better than I like computers. So I shifted into a role where I could interact with people more. And I really like being a trainer and instructor for GitLab now. This is my fourth presentation at PNSQC. I really appreciate the conference and its focus on testing. So way to go, all the volunteer organizers who keep this thing going for 39 straight years. It's amazing. I'm based in Portland, Oregon, and we like to tell our students in our classes one odd thing about ourselves, about the trainers. And so the odd thing I share is that I'm the only person I know who's had his picture on the New York Times obituaries page not once but twice. So if you want to find out more, catch me after the talk and I'll tell you the details about that very strange fact. Okay, here we go. We are going to talk about what static testing even is, kind of define the term. And then I don't want this to be a clickbaity talk where I keep you on suspense the whole time. So immediately after that, I'm going to tell you my conclusion, the TLDR of this whole thing. And then you can go off and watch another talk if you don't care about any of the more details. The more details include how do you do static testing? How do you perform it? We'll talk about that. And then we'll spend some time looking at the ways that static testing both can and can't improve your code. You know, what are its limitations? And before I go on, I'm going to try to turn on that little fake laser pointer that you can use with Zoom just to make it a little easier to see where I'm pointing. So areas that static testing can and cannot improve in your code. Excuse me. And then we'll talk about some of the downsides of static testing. No technology is a silver bullet, as Eric said. Every technology has problems. So let's not ignore those for static testing. And then, excuse me, finally, I'll summarize the whole thing and give you some recommendations for how I think you can use static testing most effectively if you decide to use it on your teams. First part, what even is static testing? So sometimes you hear it referred to as static code analysis, different term, same thing. Or if you go way back to 1978 and everyone was programming in C, there is this tool that we all know about called lint, which helped find problems in C source code. Now, the lint command is still around. You can still run it on your C code. And in fact, the term linting, as most people know, has kind of become a general term, kind of like Xerox is used to mean photocopying. Linting is now kind of used to mean perform static testing, even though lint is a specific tool. It's still around. I think modern static testing tools have probably gone way beyond what the original lint tool was able to do. But I've never used the original lint tool, so I can't say for sure. Okay, what it is is static testing just looks at your source code and looks for problems in your source code. It doesn't run your source code and then look for problems in the executing code. That's what dynamic testing does. And when I say dynamic testing, I mean the kind of testing that we're all very familiar with. You write some unit tests or functional tests or whatever, you run your code, you exercise the code by pointing the unit tests or functional tests at that running code. That's the dynamic testing that most of us spend our time on. And static testing is the opposite of that. Static test tools, some of them, can also scan files that don't hold strict code. So for example, XML files or JSON files. Some of them can scan configuration files, like if you're doing a Java project and you're using Maven to build your project, then you know you use a .pom file to kind of describe the structure of your project and its dependencies. So static testing tools can look for problems in your POM files. They can look for problems, even things like markdown files, believe it or not. So static test tools look at more than just, .java or .rb or .py files. Most of them will categorize the problems they find according to severity to give you kind of a hint where to look first. So they'll say, hey, I found 3 critical problems and 7 high priority problems and 2 low priority problems or whatever. You may not agree with the severity that the tool gives automatically, but at least it gives you kind of a starting point when triaging. Some of these tools will either suggest fixes to problems that they find in your source code, or if the static testing tool is built into your IDE, it might just give you the option to, hey, should I go ahead and fix this for you? So, like one-click fix of problems they find. So that's kind of great. And then some tools have kind of a built-in feature, like the GitLab static testing tool will show you like a delta in static test results between the code that's in your main or master Git branch and the code that's in your feature Git branch or your hotfix or your bug fix Git branch. So your non-default Git branch. And it'll say, it might say, hey, there are 3 extra problems that I've discovered just in your feature branch that don't exist in main. And hey, you also fixed one problem that existed in main that's I'm no longer seeing in your feature branch. This is a great feature because it lets you know if the code you're working on right now in your non-default branch, is it making the project better or worse? If you were to merge it into main, would that make things better or worse? Even if the static testing tool itself doesn't automatically support that, you can usually rig up some mechanism in your CI/CD pipeline that will give you this sort of diff between default and non-default branches. Anyway, it's a cool feature. I really like it. I use that all the time, that last feature. Okay, here's the conclusion. When I say, can it simplify your life? What I'm really asking is, can you replace traditional dynamic tests like functional tests or unit tests or performance or security or any of the tests that you and I deal with every day? Can you replace those with a tool that really doesn't take any setup effort? You don't have to write tests for it. You're not writing JUnit tests or whatever. You're just kind of pointing the tool at your code and telling it to go. So can you really replace all these tests with that kind of tool? And it turns out there are really no royalty-free drumroll GIFs that I could find on the internet. So you get this really simple static drum. And the answer is not really. You can't really replace dynamic testing. Static testing doesn't really replace dynamic testing, but it complements it really nicely. Think of it as a brother or sister to dynamic testing, and having both in your arsenal, your test arsenal, is way better than having just one. We'll talk later on about some of the ways it's different than dynamic testing in terms of what it can and can't catch. I think the best way to think of static testing is not as testing to find bugs, but think of it as testing to find risks. And Eric talked a lot about risks. I like his definition of risk as being the likelihood that something bad will happen times the impact if that bad thing does happen. That's always the way I've thought about risks, and I think it works here too. We'll talk later on about what I mean exactly in this context by risks, but again, think of static testing as identifying potential problems, risks, rather than, hey, this is a bug, which is what dynamic testing is good for. And finally, I recommend you try it. Now, I'm not saying I recommend you use it, because it'll work better for some teams than others. But I do think that it works for a lot of teams. So definitely try it. You've got nothing to lose, and we'll talk about how you try it. And then if it works, great. You've just improved your software. You haven't simplified your life, but you have improved your software. How do you do it? How do you perform it? There are lots of ways of adding static test tools to your build process, your software development lifecycle. So the easiest way is just use it right inside your IDE as you code. So if you're a fan of the JetBrains IDEs like I am, I mean, I consider IntelliJ IDEA to be one of the best programs ever written, and I use it every day and I love it. It has static testing built in. Anytime you see a red squiggly or a gray squiggly, I forget what color it is, under some of your code, that's IntelliJ saying, I've just performed some static testing on your code and I think I've found a problem. So you might not even know that you're doing static testing, but that's an example of it. All the major IDEs have plugins available, so you can get static testing tools and plug them into your IDE. So this is a good way to do it. If you use a build tool, like I've already mentioned Maven, but maybe you have a Java project that uses something like Gradle, or a Ruby project that uses Rake, or a C project with Make, you can always find a way to insert static test tools into your kind of chain of build tools. So you can declare one of the static test tools as a dependency in Maven, and then Maven will just run it with the right Maven target. If you have if you've kind of outsourced your CI/CD pipeline to something like GitLab or Travis or CircleCI or Jenkins, any of the lots and lots of systems that we use for our pipelines, there are always ways of plugging in static test tools into those pipelines. So that's always a possibility as well. There are also services. This was kind of a surprise to me. There are services that you can pay for. What is the one I'm thinking of? Sonar Cloud is one that does this. You pay them money and you send them the URLs of your Git repositories, if they're stored on GitLab or GitHub or Bitbucket or wherever. And then Sonar Cloud, or any of the competitors, will reach out with your credentials to that repository, slurp down your code, analyze it, and then give you the results in a web page. So I think of it as static testing as a software service, static testing as a service. That's another way to do it. You can even get extensions for Chrome, Code Climate as an extension, where it will just, if you visit a repo on GitHub, I think, it'll scan the code on that repo and tell you what it finds. And then most of the tools that do static testing have good old-fashioned, CLI commands. You can just run them from the command line. And that's great because it means you could integrate it into whatever kind of homemade, hand-rolled pipeline you have set up on your team. So these are all options. And then they kind of fall into three categories. A lot of these static test tools are open source and free. Some of them are paid. You pay money for them. And then some are hybrid, where you pay money, but behind the scenes, they're just using the free open source packages. Although usually with some extra value added, like really nice output, easy to parse results, things like that. So these are all legit ways of using static testing. There are probably 20 or 30 major static testing tools. I'm not endorsing any of these, but if you just Google around, these are the names that crop up most often. I especially like LGTM, looks good to me. I like that name. I don't know if it's how good it is as a tool. PMD is Programming Mistake Detector, which I kind of like. Findbugs is the one I remember from like 10 or 15 years ago. It's been around forever. It's maybe the most mature, but for some reason it changed its name recently to Spotbugs, but it's the same software. So these are all kind of options. Let's see. I think there was something else I was going to say on that page. No, there wasn't. So what can static testing actually do for you? Like, what are the kinds of problems it can find? It depends a lot on which of these tools you use. Some tools literally check only a single problem, and it's a very specialized tool. Often it's like a security problem. And others, like the static testing that's built into IntelliJ IDEA, do hundreds of checks. So it all depends on what tool you're using. It also depends on what language you're using. Some tools, like semgrep, run against multiple languages, but they look for slightly different problems in different languages. So it all depends is the answer for what kinds of things static testing can help with. But let me give you just a general picture of the kinds of things. So I have 9 different categories. This is category 1, and it's identifying times when your code breaks best practices. I have code on each of the next 9 slides. Don't worry about, understanding it or absorbing it all. Some of it's in Java, some's in Ruby, some's in Python. I will walk you through the important parts that I want you to pay attention to. Just think of it all as like pseudocode and don't get bogged down in what exactly it's doing. When static test tools look at your code, one of the main things they do, I think the most useful thing they do is spot ways that your code might technically work, but it doesn't quite work the way you should. It isn't programmed quite the way you should have programmed it. So you can also refer to this as code smells. We've all heard that phrase before. It just kind of smells funny. It works right, but down the road it might cause problems. Or I like to think of it as risks. It's finding risks. Your code works fine now, but by writing it in this particular way, you're increasing the risk that it will be unmaintainable in the future, or unreadable in the future, or bugs will crop up in the future. And that's why I've got this fire risk meter up here. I think of static testing as identifying how risky your code is. So let's look at some concrete problems with this code. First of all, if you're a Java programmer, you know that you don't need to import the string class. It doesn't hurt to have line 1 in, but it's just an extra line of code that you can delete. So static testing will point that out. Maybe more importantly, this conditional, this if-else, works exactly as you'd expect as it's written right here. But the best practice is you'd want to put an open brace right here, and a closed brace right here, and an open brace here, and a closed brace at the end of this. That makes it less likely that you'll introduce bugs later on when you start adding more lines of code under the if or the else. So again, it works as written, but it's risky. That's the kind of thing static testing can point out. And then this is just sort of a, what's the word I'm looking for? Not protocol. It's just sort of a team standard. A lot of teams like to have only one exit point per method. So there's only one place the method leaves, exits. And here we've got 2. So 2 different return statements. Again, this will work just fine, but you're kind of breaking the team's, their self-declared best practices or standards. So I kind of think of static testing in this role as kind of like analyzing your lifestyle. It might say something like, hey, you're perfectly healthy right now, but if you quit eating so many onion rings and you go for more walks, you'll have fewer risks, you'll have fewer health problems down the road. That's kind of how I think about this. Okay, next category is when you violate naming or formatting conventions. And you could say this is really just a part of the best practices that we just saw, but it's such a common thing to do, to violate naming or formatting conventions, that I think it deserves its own slide. So here are some problems. This is Java again, and so Java classes have to start with a capital letter, and the Java compiler would catch that, but as part of shifting left, it's nice if you can catch that before you even feed this code into the compiler, so the static tester would spot that. And then here we have a method which returns a Boolean, and the method's called bool bar. And if anyone was a programmer, especially with Microsoft languages, say 15 or 20 years ago, Microsoft really pushed this convention called Hungarian notation, where you put the return type of a method as part of its name. So this would have been considered good practice 15 years ago if you were writing in Visual Basic, but it's not really anymore. It's considered wordy. So static testing might say something like, hey, get rid of that word bool, just call the method bar. In fact, it might be even smarter than that and say this is a method that returns a Boolean, so you really should call it is something or has something. Like that's often the tradition to use with methods that return Booleans. And it could also notice you have too many blank lines here between this method definition and this method definition. Java doesn't care about white space. This will work totally fine, but you are breaking your team's conventions and making your code harder to read by adding that extra blank line. So this is a Python example. Anyone who's ever cut and pasted code knows how hard it is to keep track of duplicated code. And static testing is great at identifying places where you can strip out some duplicated code. So for example, it'll say, this foo method is identical to this bar method. Let's just delete bar completely. You don't need that. It also can be smarter than you might expect, and it might say something like, your lines 8 and 10 are identical. So whether or not Quux is true, you're gonna increment the variable I no matter what. So let's delete lines 7, 8, 9, 10 and just replace all those with I plus equals 1. So static testing would suggest a way to reduce your code in this chunk by, what, 75%. That's really useful, I think. Now, it's easy to spot these problems right here in the code I'm showing you, because these are like streamlined, simplified examples. But if you imagine this as being real-world code with lots of, hairy if-then statements and lots of complications, it gets much harder to spot these problems. And that's where static testing can really bail you out. Unreachable code is kind of similar to duplicated code, not exactly the same. Static testing might mention to you, hey, you define this method foo here, but you never call it. So you should just delete the entire, lines 1 through 9. You don't need any of them. So that's a useful way of keeping your code base shrunken, as small as possible. It also, again, this is where some smarts come in. It'll notice, your setting is bar to false. It's always going to be false. So this line 5 is never going to be executed. Line 4 will always be false. This will never execute. So get rid of lines 4 and 5 completely. Static testing will tell you that. And then it will tell you, this is an obvious one, but because the method returns here in line 7, you're never going to get to line 9. So it'll tell you to delete line 9. Again, easy to spot in this example, much harder to spot in the real world when your code gets more complicated. Okay, time check now. It's 9:55. We got started just a little past 9:30. I'm going to speed through the rest of this. Static testing cannot tell you if you're meeting performance goals, but it can tell you if the way you've decided to implement an algorithm is maybe not as fast as it could be. For example, if we're in Java and we have a string buffer, which just holds a string, and we want to find out if that string buffer is holding an empty string, lines 3 and 4 look identical to me. I mean, they both look like they would work, and they do work. And what I might not realize when I choose either line 3 or line 4 is that line 4 is 40% faster than line 3. And good static testing tools can point that out to you. So you can use line 4 instead of line 3. They can even say, hey, if you're not concerned with thread safety, why don't you replace line 1 entirely with line 7? Let's use a string builder instead of a string buffer, and then you get a 5,000% speed increase. So that's a super great thing that, a new or intermediate Java programmer might not know about. So you can actually learn a lot from the results of static tests. Here's a Ruby example about how static testing can help you with security. In this first snippet, we're using an obsolete hashing algorithm, MD5, which really isn't considered cryptographically secure anymore. So static testing would encourage you to use a stronger hash function instead of MD5, and it might even suggest a stronger one for you to use. And then here in lines 4 and 5, we're getting some input from the user in line 4, and then we're plugging that input into this command. We're shelling out, and we're including that input in a command that we're running in the terminal. So a malicious user could put something really kind of nasty as input. They could have a normal file name and then semicolon sudo rm minus rf star or something. And then if you don't validate that input, they can do all sorts of terrible things to whatever machine this code is running on. So static testing can notice that and say, hey, this line here, line 5, is potentially open to command injection like I just described. So you might want to validate this file name variable first. Complexity. There are really two main measures of complexity that static test tools use. One's called cyclomatic complexity, which I've never been able to understand how it's calculated. And the other is cognitive complexity, which makes much more sense. And static testing could point out that all the sort of gnarly conditionals in this just make it essentially impossible for any human to understand. High cognitive complexity warning, and it might advise you to refactor this code. It might even give you suggestions on how you can simplify this code. Sometimes there's a logically equivalent conditional that you didn't even see, and something like IntelliJ or other static test tools can suggest, hey, do you want to replace these 4 lines with this 1 line? And you're like, of course I do. That's a great improvement. So this is a useful role for static testing. Documentation. Back to Java. So this is an example of JavaDoc. We've got a method down here that takes 2 parameters, I and j, get passed in. But our JavaDoc for documenting this method only talks about the first parameter. So we're missing a description of parameter j. We also don't describe what this method is returning, so that's missing. We also have a to-do statement down here. And, sometimes to-do statements are necessary, to-do comments, but it's good to get rid of them when you can. So static testing will point out when you have a to-do or a fix me or something in a comment. And it will even notice, I thought this was pretty clever. I didn't know this was possible. You can blacklist certain words, like inappropriately gendered words. And it can say, hey, do you really want to use the word guys in your Java doc? To increase sort of friendliness and inclusion in your code. It can also notice that this Java doc is not attached to anything else. It's not attached to a class or a method. So it will confuse the Java doc generator when it parses this file. This is the last one, the last of my 9 ways it can help you. Spelling and grammar. Programmers are more interested in code than in English, so it's not unusual for them to make mistakes that a static tester can spot, like options is misspelled, your mistake. It can even say something like, you don't really need the word of. Review all your options. Works perfectly well. And in fact, I learned a lot about how to make my writing more powerful and impactful. Okay, 5-minute warning. Here we go. Speeding through this. I learned a lot from IntelliJ, so it's great. It can even notice that, hey, you're not formatting your date the way your team wants these things formatted. Okay, so that is the last of the ways that it can help you. Here are some of the ways static testing cannot improve your code. If your algorithm doesn't match your product's requirements, you're building the wrong product, static testing can't catch that. Dynamic testing can, if your unit tests or functional tests are well written. So like if you're sorting by first name and you should have been sorting by last name, static testing won't notice or care, whereas a well-written dynamic test will. If you've got the right algorithm, but you've written it incorrectly, like maybe you have an off by 1 error, we've all run across those, or you pass in I and J when you should have passed in J and I, or you use and when you should have used or, static testing will not catch any of those. Dynamic testing will catch all of those if you write your dynamic tests correctly. I've already mentioned that if your program is working slower than you want it to be, static testing is blind to that sort of thing. It can't catch integration errors where code works in isolation, but you combine it and stuff breaks. Static testing doesn't know about that. Same thing with configuration errors, setting up your environment. So those are all things that dynamic testing does catch, static testing does not, which is why you can't replace dynamic with static. Extra downsides to static testing. False positives is the biggie. Static test tools give you tons of responses, identify all sorts of things, many of which you might not care about. Going through all the things that static testing tells you is slow and expensive, even if static testing gives you a lot of good results, like a lot of good actionable things that you want to fix. It takes a long time to sort through all those. And frankly, it often gives you a lot of things that you just don't care about. Like, yes, technically that's a problem. We don't have the time or money to really fix it. We don't really care. It's a small problem. The risk is low. Go away. That happens all the time with static testing. Some static tests are lickety-split, like just takes a few seconds to run. Others can take a minute or two, even to test a trivial 2-line Python program. I think mostly ones that are pulling Docker images down take a long time. But there are various reasons they can be slow. Here's one that really bothers me. There is no standard reporting format among static test tools. There's no equivalent to like junit.xml, the results from JUnit. So you kind of have to cobble together a system that parses the output and puts them in a form that you can absorb. Here's my summary. Sorry, I'm speeding through this really fast. My summary is, it doesn't replace dynamic testing for all the reasons I've given. It's blind to a lot of the categories of problems that dynamic testing is not blind to. Dynamic testing will see. Static testing finds risks, not bugs. And the problem with that is it can take a while for spotting risks to pay off. It's like if I stop eating donuts now, I'm not going to notice any difference in my health tomorrow. It might take 20, 30, 40 years before my lowered heart attack risk starts paying off. Same thing here. Improving your code by shrinking it, by removing duplicate code, is not going to make any difference tomorrow, but it might really pay off in maintainability 6 months from now or a year from now. I recommend you try it, and if you do try it, I recommend you shift it as far left as possible. So in other words, if you can do static testing with an in-IDE tool, that's probably the best way to do it. Tune your tools to the extent you can to reduce the number of false positives, so that reduces your triage effort. And then triage everything that comes through. If you don't, your whole team will just start ignoring the results of the static test tool, and you'll throw away the static test tool. We've all seen this happen with other, sometimes dynamic testing tools. I think that is it. In summary, it's a good technology. I like it. I recommend you try it yourselves, and I hope it works out well for you. And that's it. So Q&A.
Awesome. Thank you, Chris. Any questions from anyone first in the audience? I know I have some questions, but I'll try not to be too selfish here. Any questions from anyone? I didn't see anyone post anything in the chat. If not, I won't waste time. So, Chris, this was exciting. Thank you for such a great talk. I guess some things that kind of came to my mind as you were going through was, first, what about trends? Like, I mean, we're seeing a lot of work around automatically, not just checking code and doing IntelliSense, but we're seeing like the GitLab Copilot like generate entire functions and stuff like that. So I was wondering, sorry, did I say GitLab Copilot? I meant GitHub Copilot, not GitLab.
I'm used to the confusion.
No, I'm not confused, but I guess I say that because I know this wasn't about your product, but I'm curious as to just what new technological directions GitLab is making around here. What do they see the future of this technology to be?
Yeah, it's interesting you asked that. Again, I don't want this to be a GitLab ad, but I know more about GitLab than I know about the other tools, so that's the one I have to talk about. Their big emphasis now is on increasing the range of languages that static testing can cover. Now, GitLab uses open source static testing tools behind the scenes. We don't write our own. We don't want to write our own because open source people will write it better than we will. We'd rather rely on that. Just like for security, you want a security expert to write your security scans. So we can't really control what languages have static testing tools available. But when we see that new tools are available for Rust or for Go or for some new language that just crops up tomorrow, and they seem mature enough to be useful and reliable, we'll incorporate them. So I kind of feel like a lot of the static testing open source projects that I've run across are fairly, I was going to say static, but that's not what I mean, fairly mature. They're not changing a lot anymore. I kind of feel like, yeah, if new security vulnerabilities are discovered, they might add those to what the static test tools are looking for. But for the most part, the static test tools have identified, here are the 20 things that people often do wrong. Let's make sure we cover those. And they do cover them. So there's not a lot of need for like constant improvement of the static test tools. They're fairly mature that way, which is nice. It means we can rely on them.
Can stabilize, great. And Rachel had a question here. I know I had a similar thought as well, but her question is, are there any integrations of static testing tools into bug reporting software? And do you recommend these if they exist, or does it make triaging kind of ruthlessly? So any kind of recommendations on that? I think the whole idea is, we got the static information, as you mentioned, but we also have this dynamic information. How do we make use of it all together in kind of one space?
Yeah, I don't know about any specific bug reporting software that I can talk about how it integrates with static testing. I will say there is a challenge that I mentioned already, which is the no standard output format for static test tools. Everyone spits out their results in a slightly different way. And that is a challenge. It means that if you're using more than one tool, you've got to learn to visually parse, different kinds of output. Or if you want to feed all those things into a home-built dashboard or something, you can do that, but you've got to parse each tool's results slightly differently to make it all fit into the dashboard. That's maybe my least favorite aspect of static test tools right now. Rachel, I don't know if that answers your question exactly, but that's kind of where it stands right now, I think.
Yeah, I think, either you have to deal with integrating everything into one separate dashboard solution like Grafana or something, but there's usually an integration challenge there for sure. So Rachel says that makes sense. So we have one more minute. Any other questions from anyone? Again, this was just very insightful, Chris, and you did a really good job to summarize some key points. So I know that was worthwhile. So
thank you.
All right, well.
Happy to entertain follow-up questions on email if anyone wants.
Yeah, sure. So feel free to reach out to Chris. This was great. Chris, I just want to thank you for a great talk. And I'm sure you'll be around the conference, so feel free to reach out to Chris. And thank you for having me. I do have one other question, Chris, because it's been bothering me ever since you turned on your camera, which is this a real background or is this fake? I can't figure it out.
This is my windowless basement. Yeah, that's a real background. Those are all my college books from a million years ago that I've never read.
Well, it looks awesome. So thanks again for joining. So
Thank you.
take care. Alrighty.